Hello and welcome to Chapter 8 Homework. How are y'all doing? So, again, we're going over Chapter 8, which is great. Gotta keep doing that because it rhymes in the time. Anyway, so we're going to handle 10 more questions in our homework. And again, you know the drill. If it seems to repeat, which I probably would say Chapter 8 doesn't have too much in work problems, may happen. Remember, I probably won't go over it as I want to test your skills. I may do, may not. We'll find out as we move forward. So starting off first. Listed below are the 35 members of the Metro Toledo Automobile Dealers Association. We would like to estimate the mean revenue from dealer service departments. The members are identified by numbering them through 00 through 34, so 00. But there's no 007. We would like to select a random sample of 5 dealers. The random numbers are as such. Which dealers would be included into the sample? Let's see if it has the numbers. Okay. So, all really for this question, is that basically, let me remove that. All you're doing is putting in the numbers to which ones would actually qualify in the order. Okay, so that one is not crazy. Since we only have 34, you can't do any numbers that are higher than 34. So like 38, new. There's only going to be 5 of the numbers that actually work. Then B uses a systematic random sampling that every second dealer is selecting, starting with the 5 dealer in the list. So, starting with 5, again, hit check. And since we're doing a systematic approach, it's every second dealer. So every second dealer, so 5, probably going to be 7. Let's see. Yep. So basically just adding 2 till you get through all the blanks. Again, your numbers may change of where they start at. But basically, you start at whichever dealer that you go with, and you count basically 2 for this one. So make sure this question 1 seems more likely just need to be reading. It seems like. Again, we're just testing your randomly sample skills. Yes. All right. Question 2. All right. Population consists of the following 4 values: 34, 12, 36, and 16. List all samples of size 2. Compute the mean of each sample. Let me see. And they have a drop down. So we would have 12 and 16, 12 and 36. Then they go 34 and 12. We'd have that. We would have a 34 and 16, 34 and 36. Wow. So sometimes you do get amazed. Okay. So remember, when we're dealing with this, since basically the whole drop-down bar is every one of the values, make sure you pop up your calculator. Add them together. That will give you 28. And then divide by 2 will give you 14. Because there's only 2 numbers. So that's really what you're doing with part A. So again, I'll take my calculator, add my 2 numbers. Make sure I put that in. And then divide by 2. There's your mean. And then you can hit check my work, or you can go through the whole table and then hit check my work to see if you've missed any of the answers. But that's all with part A. Let's see what part B has. Alright, compute the mean of the distribution of the sample mean and the population mean. Compare the 2 values. Okay, so we do have to finish all of this. Complete the dispersion. Okay, nice. So real quick, population mean would be this. Population mean is the easy one, plus 12 plus 36. So it'll be 98 divided by 2, not divide by 2. 98 divided by 4, 24.5. Okay, so with the sample, we actually have to pull all this together. So, calculator, let's go ahead and do that real quick. So that's 46. Divide by 2, it's 23. 34 plus 16, it's 50. Divide by 2 is 25. 34 plus 36, 70. 2 is 35. Then 36 plus 16, 52. And that one actually is going to probably be, okay, 26. All right. Then we compute the mean. 14 plus 24 plus 23 plus 25 plus 26 divided by 6 equals to 24.5. Okay, so all we do when we're doing the sample mean is we add up all the means, the ends to the means, and divide by 6. Sorry about that. And then once we have both numbers, again, check your work. Make sure everything is hitting the check marks. So the means are equal. So it does mean the sample mean should be more dispersed because they're, yep, populations are more dispersed than the sample. Basically, the population is a little bit big, smaller. So it has to be more dispersed because it's going from 12 to 36. While this one, you can see most of the numbers are actually closely together. Here, there's big leaps. So sample is not as much as dispersed as our population just because of that. Okay, that's question 2. Question 3. Question 3 is exactly the same as question 2, except they add one more twist by giving you 10 ones. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 6. So it looks like they're going to rotate through these. So let's see how this goes. Or we got repeat numbers. I might have done 2 by accident. Alright, let's see. So we have 2 ones. So we should have a repeat of 1, 1, 1, 1, 1, 1. So it should be 2 1 6 8s. Yep. 2 1 6 9s and 2 1 8 9s. So let's check to make sure we got them all. Yeah. Alright. So you have to watch out for that because there is a repeat of the 2 1s. That's why there's only 7 that you can select from. Because 3 of them are going to repeat. And again, we would take the sum of each one. So, and then you find the mean. This time, instead of divide by 2, we're going to divide by 3. Okay. Then again, you're going to total them up and divide by 10. That will give you your sample mean. Population mean is again going to be 1, 1, 6, 8, 9. So all 5 of these values, add them together and divide by 5. Then you're going to see if they're equal or not. So, and then the range of the sample means is either going to be less than, equal, or greater than. Really all that question 3 is. All they did is change from question 3 from question 2 was move it to 3 values. But don't get caught. Okay? Have to remember what what the mean is. Okay? Wow. So, I'm going to leave y'all with that. I think y'all got this. Let's go ahead and move on to question 4. Okay, so question 4 is going to bring in some more math base with the z value. Okay, because we're going to look at the central limit theorem. So we have a normal population has a mean of 61 and a standard deviation of 13. You select random samples of 9. Apply a central theorem to describe the sample distribution of the sample mean with n equal 9. With the small sample size, what condition is necessary to apply the central limit theorem? Okay. So, first off, the condition always has to be normal. Okay. I don't know why they have a huge gap between A and B. That's a little bit odd. Next, we figure out what the standard error of sampling distribution is. So again, I like to go ahead and reference our chart, or basically our PowerPoint, so you can see the formula. Yes. So, this is the formula. Standard deviation divided by square root of our sample size. Okay. So, for us, calculator, 13 is my standard deviation divided by the square root of 9, which gives us 4.33333333. So 4.33 is basically the standard error. Okay. Next, what is the probability that a sample mean is greater than 64. Round z-value to 2 decimal places and final answer to 4 decimal places. Okay. So, again, we need to find out what z-value is. So for our formula, it's right down here. All right. Whoa. Went a little bit too far. There it is. So remember, we have the sample mean minus the population mean, which is mu, divided by the standard deviation divided by the square root of n. So since we already know 4.33, we're going to have a little bit of rounding. We can do that, or we can be a little bit more exact. Let's go ahead and be a little bit more exact. Okay? So, calculator. We're going to take our sample mean, which is 64, minus our population mean, 61, divided by, in parentheses, 13 divided by 3, because that's the square root of 9. There we go. Z value is 0.692, but we know on our Z chart, popping up our Z chart, yeah. So, under our Z chart, doesn't really have anything past 2 decimal places. So it is only going to be 0.69. So 0.69 right here. So that's how much the Z value is worth. What we want to know is what's greater. So we're going to have to take that number .5 minus 0.2549, 2451. Okay. Remember, you have to subtract it by 0.5 because it's asking for the greater. In the Z chart, the Z chart is doing what's on the inside. So basically, we're looking at the tail. So we have to subtract 0.5 from it. Okay, what is the probability that the sample mean is less than 57? Okay, again, we'll go on calculator. Take 57 minus 61. And we're going to divide it by 4.33. Again, it's going to be rounded a little bit. It's 0.92. Table. Again, even if it's negative, we still report it as positive. So 0.9012. So it's this column. So it's 0.3212. And again, we're looking at the tail. So I'm going to take 0.5 minus 0.3212. So 1788. Well, return question. And there we go. Now I ask, what is the probability that the sample mean is between 57 and 64? Well, I can do this real quick. Let me take a calculator. 1 minus 0.2451 minus 0.1788. So I'm looking at probably about 5761. Okay, there's two ways you can do that. You can add the decimal, the probability that you got when you calculate the z-value, or you can do exactly what I just did, since we already solved for the two tails that they're using. We can just subtract them from 1, and that will give us our probability of the 57. Alright, last one. Turn to question. What is the probability that the sample error would be $9 or more? That is, what is the probability that the estimate of the population mean is less than 52 or more than 70? Alright. So with this one, again, we're going to have to figure out what z-value is. And this is taking either one since they're all both the same distance away, $9. So I'm just going to take the upper limit. Calculator, 90, not 90, my bad, 61, 70, dang, I can't type, minus 61, divided by 4.33, we're looking at 2.08, so again, z-chart, we're now going to find 2.0, this is going to be 8, okay, and since we know we're looking at which way it goes, we're going to now take this amount and subtract by 0.5. 0.5 minus 0.4878 equals to 0.0122. No, I have the wrong thing highlighted here. That's what I get when I have old things highlighted. Sorry. 0.5 minus 0.4812 equals to 0.0188. Times it by 2, since we're looking at two tails, equals 0.0376. Again, check. Make sure I didn't get that wrong answer again. So, with that, it is a two-tail, and since they're evenly apart from each other, from the mean, it's almost your empirical rule going on here, we can properly calculate the same for both tails, and mostly it's just like adding the two tails together. Okay, that finishes question 4. Okay, question 5. Always do that. Alright, so this one goes, in certain sections of Southern California, the distribution of monthly rent for a one-bedroom apartment that has a mean of 2,175 and a standard deviation of 250. The distribution of the monthly rent does not follow the normal distribution. In fact, it is positively skewed. Okay. What is the probability of selecting a sample of 70 one-bedroom apartments and finding the mean to be at least 2,115 per month? Now, normally, we do want a normal distribution, but we can only go the way that we can. So we're going to take our calculator. Again, we're going to calculate the z-value, which for this is our sample minus our population mean. This one's going to get divided by our standard deviation of 250 divided by again, the square root of 70, our sample size. Close parentheses. So we're looking at negative 2.01. Okay. So using our chart, 2.01 is right here. Okay. So that's 0.4778. Now they're asking for the probability for the mean to be at least this. So we're not going to do any subtraction. There's no need. So it should be 0.4778. Okay, they do want the subtraction. That's a little bit odd. So let's go ahead and do that. 0.5 minus 0.4778. Go 0.0222. Huh. We have an interesting factor here. Okay, so we had to redo question 5, so sorry about the skippage. It was a little bit off. I found out that that one somehow there was an error with it, but we figured out the new one. Okay, so again, this is the steps to finish question 5. We need our calculator. And we're going to still do the same thing with the z-value. We need to take our sample mean, which this time is 2,245, minus our population mean of 2,325. Okay, so we're left with negative 80, divided by, in parentheses, our standard deviation, divided by the square root of our sample size, which happens to be 50. Alright, so this will equal to our z-value. Again, round to 2 decimal places, so we're left with 2.1. So coming to our chart, this will be 2.1 right here. Very quick, since we're already down there. Whoops. Not that 2.1, that's 2.11. Sorry. Here's 2.10. So 0.4821. Okay. So, using our calculator, sorry, just trying to find a good position for it. We take 0.5 minus 0.4821. Okay. Leaves us with 0.0179. Then I'm going to subtract 1 from it. Will give us 0.9821. Check. So the biggest problem with question 5 is to remember 1, you still have to do the z-value. 2, subtract what the z-value 4 decimal places are from the table by 0.5, then subtract that from 1. Okay, and that's where we end up with 0.9821. Okay, sorry for having the previous problem. Again, had to restart it. That's fine. I just want to make sure I show you the correct way of doing it and that it's coming out correctly. So, hopefully, understandment. If you have any questions, again on that, because the video is kind of like that, please let me know. All right. Question 6. The quality control department employs 5 technicians during the day shift. Listed below is the number of times each technician instructed the population foreman to shut down the manufacturing process last week. So we have 3, 1, 3, 3, 2. How many different samples of the 2 technicians are possible from this population? Okay. So, how many could we have? Well, I like this. B actually helps us list this. So we can have 31. In fact, you can have 31 multiple times. So 31, 31, 31, 2, 1. Okay. So we can have 3, 3, 3, 3, 3 times. Okay. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3. So we eliminated those. We eliminated 1. Next, it's 3, 3 2s. Check. Oh, they won't take the 31s, which is odd. Because we can take 1, 3 here, 1, 3 here, 1, 3 there. Okay, wonder why. Oh, they may want 1, 3. Yeah, they just want it the other way. Hey, it is what it is. We'll go with it. Okay? So this actually shows us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. So I could have done it that way, or we can have just done simple 5, 1, 2, 3, 4, 5 times 2. Works either way. Okay, now I want you to find the means. Now remember, this is just like question 2 and question 3, but we're going to go ahead and knock it out. So 1 plus 3 is 4. 4 divided by 2 is 2. 1 plus 3. Okay. 1 plus 2 is 3. Divided by 2 is 1.5. 3 plus 3 is 6. Divided by 2 gives us 3, 3, 3. Okay. 3 plus 2 is 5. Divided by 2 will give us 2.5. 2.5 and 2.5. Again, those are pretty easy to do in the head. But if you still need a calculator, that's fine as well. Never be shy to use technology. And never be shy to make a mistake. Like I've done. And had to correct in the video. Some stuff just doesn't work out the right way. Anyway. Turn to question. We want to find the population mean and the sample mean. So I'm going to go ahead and do those for you. We're going to take 2 plus 2 plus 2 plus 1.5 plus 3 plus 3 plus 3 plus 2.5, 2.5, 2.5. So we're seeing at 24 divided by 10 is 2.4. Okay. Population mean. It's up here. Calculator. 3 plus 1 plus 3 plus 3 plus 2 is 12 divided by 5. Happens to be 2.4. So the population mean is equal. Check. Everything is correct. And that is question 6. Okay. Question 7. Okay. Question 7 is pretty much exactly like question 4. So again, normal, maybe actually skewed, but we want normal. Yeah, okay. Makes life a little bit easier. Then it's find the standard error and the probability of each one. Again, not much difference here. So, yeah, let's try 8. See what 8's doing. 8 is doing the same thing as question 7. And we're also seeing it for question 9. Is question 10 doing it? No, question 10 is a little bit different. Okay, so 7, 8, and 9 are just like question 4. And since this is mostly what chapter is, I kind of want to see how well y'all do. If you have any questions, please let me know about it, and we'll make sure we get it all solved for you. Question 10. Let's see what question 10 is, because it is a different format. It goes, Crossett Trucking Company claims that the mean weight of its delivery trucks when they are fully loaded is 5,600 pounds, and the standard deviation is 230 pounds. Assume that the population follows the normal distribution. 40 trucks are randomly selected and weighed. Within the limits of what limits will 99% of the sample mean occur? Round your z-value to 2 decimal places and final answers to 1 decimal place. Okay. So we're looking at what limits will 99% of the sample means occur? So let's find our z-value. We have 99%. So really, if we're looking at 99%, we're going to be taking our z-chart. I think we're actually going to take z-chart. Take our z. And calculator. 99 divided by 0.99 divided by 2 is 0.495. So let's find 0.495 through all this C. So we're going to look at 2.57. 2.57. Oh, this looks like it's going to be more of an algebraic. Let's find out. So 2.57. Okay. So, question is what limits will 99% of the sample means occur? So if we know the z-score would have to be 2.57 to hit 99%, let's see. All right. I actually have to think this one through a little bit. This one's good. So we're going to start with standard deviation. We're going to keep the 2.57. Okay, so let's figure out standard deviation is 230 divided by the square root of our number sample. Alright, so it'd be about 36.36 cell 4, so 36.37. Then we multiply it by our z-score for 99%, which is 2.57, due to not knowing the sample mean. Okay, that leaves us with 93.47. So we know that the mean, so basically what I'm doing to show you, okay, here's the formula. And what we're doing is we took this first, the error, and multiplied by z because we're missing this number. So we know we minus 5,600, which is mu. Here, we need to add that. So it looks like we're sitting at 5693 to get our positive. So about 5693, so we're off by 93-ish. So we know upper limit, it's probably going to be 5693. Final answer is to 1 decimal place. So 0.4 or 5. Yeah. 5693.5. We're going to see. Yep, there we go. They had used algebra on the last one. So, calculator. We take 5,600 minus 93.5. 5,506.5. And there you go. Good thing, I mean, it was a work right there. So really, all you have to do is get to taking your standard deviation, divide by your square root of the sample size, which is the error, and then add or subtract 5,000, how much poundage, what the mean is, and that will get you to your answer. All right, nice. So if you stayed here and listened to that explanation, I think we should be good to go. Again, if you have questions over 7, 8, or 9, let me know. Again, they're just a repeat of question 4. And I really want to make sure y'all understand these questions and able to get enough practice in. Okay? Because most likely we're probably going to see one of these on the exam. Okay? So I wish y'all very well. I will see y'all next time.